In this video, I'd like you to jump to page, I think it's 164. I want to just jump into some practice problems and then we're going to go back. So I'm going out of order because I do want to solve maybe one or two more systems of equations by graphing. So let's look at number 2. Let's graph this system of equations. So I rewrote everything here. 2x minus y equals 1 and x plus y equals 8. So I can't really graph this well when it's written out like this. I want to rewrite these in slope-intercept form. So maybe I would subtract 2x, from both sides, right, minus 2x. And that would leave me with negative y equals negative 2x plus 1. And then if I divide everything by negative 1, let me erase this. I'll rewrite it later. Okay, so if I divide everything by negative 1, then I'm left with positive y equals 2x minus 1, right? 1 divided by negative 1 is negative 1, and negative 2x divided by negative 1 is positive 2x. So this we can graph, right? My b is negative 1, my m is 2x. So I can put a point down here at negative 1, and since my slope, I wrote 2x, my slope is really just 2, right, not 2x. So if my slope is 2, you could think of that as rise over run, right? I'm going to rise 2 units, right, 1, 2, and then run 1 unit to get a point over here, right? So I go up 1, 2 over 1, up 1, 2 over 1, right? So those are all my points. Right? You can see these all fall on the same line, okay? And if I get my line tool out, let's see if I can draw this somewhat okay. I'm trying to freehand this thing here. That's not bad. All right, so that was the first equation. The second equation was x plus y equals 8. So I'm going to write this on the other side of my graph, right? And to graph it or put it in slope-intercept form, if I subtract x from both sides, I'm left with y equals negative x plus 8. So my m is negative 1 and my b is positive 8. So if I put a point at my b, which is the positive 8, remember negative 1 is the same as negative 1 over 1 or 1 over negative 1. So I can do my rise is down 1 over 1, right? Down 1 over 1, down 1 over 1. And these are all the points if I go down 1 and over 1. And if I connect that with my line, and then just remember, what are we trying to accomplish here? The whole point of this is we're trying to find the intersection, right? The intersection is the solution to my system of equations, right? So that would be, that looks like that's 3, 5. Right? So I'm saying that the solution to the system is 3, 5. So if we go back and look at number 2 and put 3, I forget if we said 5 or negative 5. 5, right? 3, 5. If I put that in to these equations, it should work. So let's just test it out. If I do 2 times 3 minus 5, does it equal 1, right? So 6 minus 5 equals 1. Yeah, it works. And then if I try into the second equation, I get 3 plus 5 equals 8, or 8 equals 8. So that's me doing the check. It works. So I know that 3, 5 is a solution to this system. Okay. Let's try one more. I'm going to try number 3. Okay, I'm going to rewrite number 3 on the graph paper. So for number 3, the first equation was 2x plus y equals 5. So I want to graph 2x plus y equals 5. But we have to, again, get this into slope-intercept form, or y equals mx plus b form. So I'm left with y equals negative 2x plus 5. So my m is negative 2, and my b is 5. I should have put an equal sign in there. All right, so my b is 5, so here's my point at 5, and my m was -2, right? So if m equals -2, you could write that as -2 over 1 or 2 over -1. So in the first case, we would go down 2 and to the right 1, down 2 to the right 1, right? I'm just going to do a bunch of points here, right? Or I could say up 2 and to the left 1, right? Up 2 and to the left 1. I think that's enough points, and we can kind of connect our line. So let's try this, see how this works. That's not bad, right? Here's my line. And then the second equation was this x plus y equals 2. So again, we're going to want to write this in slope-intercept form. So I'm just going to subtract the x from both sides, and I'm left with y equals minus x plus 2. So my m is -1, or -1 over 1, or 1 over -1, and my b is 2. So here's a point at 2. And so if I were to go, let's see, down 1 and over 1, down 1 over 1, down 1 over 1, you can see this is my line. And I'll just connect the dots. Let's see. And you can see my intersection, right? The whole reason we're doing this is to find the intersection. Whoa, I didn't use my pencil tool. Right, so here's the intersection. And as an ordered pair, I think that's 3, -1. Right, so 3, -1 is the solution to this system. Right, 3, -1 is my answer. And again, you could check your work by plugging it in to make sure it works. Okay. Toward the bottom of this page, they give you graphs and they ask, can you write the equation of the line in slope-intercept form? And can you write the system of equations that represents this graph? So yeah, all right, let's do it. If I look at number 11, my b for this first line, right, you could see my b is -1. And my slope, let's see, my rise is up 1, 2, right? My rise is up 1, 2, 3. So my slope is rise over run. So I went up 3 and I went to the right 1. So my m, oops. So my m is 3, right? So my equation is y equals 3x minus 1. My ink got really thick. I want to see if I can make it a little thinner. Huh. Okay. So that's the equation for this line is the y equals 3x minus 1. And then for the second line, my b looks like it's -3. And my m, let's see here. I got a point here and a point here. So it looks like my rise is 1, 2, 3. And my run, right, so 1, 2, 3, is 1, 2, 3 also. So it's 3 over 3, which equals 1. Right, so I would write y equals 1x minus 3. Or really, you could just write y equals x minus 3. Right, that's this equation for this line. And then the intersection is happening here. So the solution would be, looks like -1, -4. And if I want to write the system of equations, I would write something like y equals 3x minus 1, y equals x minus 3, and my solution is -1, -4. And that's it. I tried to write my system sign well, but it didn't come out great. So let me try this again. Something like that. That's my system of equations. And then finally, of course, I'm always going to ask you to do the summary on the next page. Let's see if I can get to it. Yep, here's the summary. And then I did want to quickly mention, sometimes a system will have no solution, right? If I were to graph this system of equations, I get parallel lines. So the intersection is my answer. So if parallel lines never intersect, I don't have an answer. The answer would be no solution, okay? So if you graph two equations and you end up with parallel lines, there is no solution, okay? There it is. There is no solution. Right, so that's one thing I want to make sure that you're aware of. Sometimes there is no solution. And then one other thing. Here we go. Sometimes there's an infinite amount of solutions. If I graph these two lines, turns out they both fall on this line, right? So I basically have two lines on top of each other. So if I try to graph two equations and I end up with the same line, we would say we have infinite amounts of solutions, right? Here we say there are infinite solutions, all right? Thank you for watching. Have a great day.